Okay, so let's have a look at this question here. Let's get rid of this. So what it asks you to do, so it says A, B, C, D. So these are 4 points, A, B, C, D. So you have A here, B, C, and D. So A, B, C, D, and A, E, B, D. So A, E, B, D. Okay, so you kind of have this shape here. So it goes up, down, and then across here like so. And AEFC. So where's AEFC? So AEFC are parallelograms. Okay, so this is a parallelogram, this guy here is a parallelogram, and then this here is a parallelogram. The area of ABE, so the area of ABE, so this here is a triangle, you see that it has 3 points. So ABE is 12 square units. So if we just shade that in blue, okay, so it's A, B, E, so it's kind of this triangle in here. So it tells us that that is 12 square units. So square units is the unit of measure for area. So we're talking about this triangle in here. So what it asks us to do then is explain why the area of ABD is also 12 units. So we're talking about ABD. So it's talking about this piece down here. Okay, so this piece here. Let's just shade it in. So it's basically saying that the question starts off by telling us that this here is 12 square units. Okay, I'll just abbreviate it. So this is 12 square units. Remember, what we have here is a parallelogram. So ADBE is a parallelogram, and you can see here that we have a bisect line. So this line goes from here, goes from one corner to the other. So if you have a parallelogram, so if you have something, let's say like this, and if you draw a line from here to here, from one corner to the other, you're basically bisecting the parallelogram into 2 equal parts. Those 2 parts will have, they're pretty much identical. They'll have the same angle, and they'll also have the same, they'll have the same angles, should I say, and they'll also have the same area as well. So that's why. Okay, so because you can say, explain why, because the line segment AB bisects the parallelogram. So that's why this piece here is also going to be 12 square units. So 12 square units. Okay, so that's the first question down. So let's just get rid of all of this stuff so that's not kind of messy looking. So that's the first part. So that's why, so we're just answering the first part. I might just leave that there just so we can see that we have 2 parallelograms. So the second part then is explain why the parallelogram ABCD, so A, B, C, D. So let me just get from here, I might just get rid of this out of the way. So we're basically saying, why is this parallelogram A, B, C, D and AEDB, AEDB, okay? So maybe I'll actually put that back. So we have, so this green outline here is one parallelogram, and then we have this blue is another parallelogram. So you have 2 parallelograms. So it says, why are the 2 of them equal in area? Well, we can say they're equal in area because we can say that, so in the first parallelogram, this part here, or this triangle, is going to be equal to this triangle here in area. So we've kind of just looked at that. So the area of this triangle here, ABE, is going to be equal to ADB. And so therefore this piece here is equal to this piece. And what we can also say is that so this part is equal to this part. And then we can also say that we can see here that the line DB, it bisects this bottom parallelogram. So therefore this side here is also going to be the same. This triangle, should I say, is also going to be the same area. So you can say that this here is 12 square units, this is going to be 12 square units, and then this will be 12 square units as well. You can say that they're equal in value because they contain similar triangles. So they contain similar triangles. So you can say that the triangle, let's say the triangle ABE is equal to the triangle ABD, which is equal to the area of the triangle BCD. So sorry, DCB. So DCB. So the areas, so this area is equal to this area, and that's the area of the first parallelogram, and this area is equal to this area, and that's the second parallelogram. So and that's why. So the third part then, so part 3, find the area of the figure ADCE. So we're talking about ADCE. So if we think about this, so all this is made up of is 3 triangles. So you have this one here, and they're all equal in area. You have this one here, 2, and then this one here, 3. So basically the area of this piece, ADE, which is this whole thing here, is going to be 3 multiplied by 12, because each of those triangles is 12 square units. And that's going to be 12 and 12 is 24, and 12 is 36. So it's going to be 36 square units. Okay. The next part then, find the area of the triangle ABC. So the area of the triangle, so ABC. So we have, let's just rub all this out so we can see what we're looking at. Let's get rid of this shape here as well. So we have, so it's asking us to find the area. So find the area of the triangle. So this means triangle, and triangles have 3 points, ABC. So A, B, C. Okay, so the area of this ABC. So again, the area of this guy here is going to be, it's going to be equal to this, which is equal to this, and it's 12 square units. It's going to be 12 square units. I'll just say square units. Find the area of the triangle ACE. So ACE. Okay, so let's think about that one. Let's just rub all this out. So where's the triangle ACE? So A is that point, C and E. So what have we got within this triangle? So we have this here makes part of it. Okay, and that's going to be 12 square units. So that's 12. And then we have this part here, which is the second part of it. And the two of these together form the triangle it's talking about, and that's also 12 as well. So 12 and 12 is 24 square units. So that's that one. Let's rub these out. And the last part then is find the area of the figure ADCFE. So it's ADCFE. So we want to find the area of this overall triangle. So what we can do is we can take this guy here and we can bisect it like so. Okay, so this length is equal, it's going to be equal to this length, and this length will be equal to this. So what we can say is that this is 24, sorry, this is 12, so they're all 12. So we have this part, which is 12, 1, then we have this part in here, 2, 3, 4, and 5. So we have 5 parts, or 5 triangles, that each triangle is 12 square units. So it's going to be 12 multiplied by 5. Let's get there. So calculator. Okay. Get the calculator. So 12 multiplied by 5. That's going to be equal to 60. So that's equal to 60 square units. So that's that one. So it's just basically calculating the area of different sections, let's say, within this shape. And a lot of the shapes are parallelograms, and when you bisect a parallelogram, you create two equal, bisect as in draw a line from one corner to the other, you bisect it and you create two equal triangles. Okay, so that's that question, and that's question 16.